Hi everyone, I'm just going to look at a few questions here that deal with infinite area. So, well, the areas that look like they should be infinite but actually aren't. There's a really famous kind of conundrum called Gabriel's trumpet that I'm going to talk about, where you've got a trumpet that looks like, let me show you what this thing would look like. You've got a simple axis here, and you take a curve that we all know, like 1 over x. There's the curve y equals 1 over x, and you rotate that curve around the axis here. So you end up with this big trumpet here, and you go from this point here. So you start at x equals 1 and go onwards. Now, you can see you get this big long trumpet that'll get closer and closer and skinnier and thinner, but it would never, ever end. And the interesting thing about this trumpet, the really interesting thing is that the volume of the trumpet is finite. I can prove to you that you could fill the trumpet up with a set amount of water if you like. The tricky thing is that the surface area of the trumpet is infinite. So you could fill it up with water, but you could never paint it. So it's kind of an interesting geometrical shape here. So what I'm going to talk about is a couple of examples here where it looks like the area should be infinite, but it actually isn't. So let's look at this first one, page 20 in the notes. We want to evaluate the integral from infinity to 0 of 3 over 1 plus x squared. So if you look at the graph, this graph actually goes on and on forever. It never touches the x-axis. And so you'd think that that area would keep going on bigger and bigger and bigger and bigger and bigger. But let's check it out and see how we resolve this one. So we know that the area, which is that green area that I've shaded there, is that integral there. So let me just write it a little bit differently. So I'm going from infinity to 0 of, let me put the 3 out the front, and I'm going to call this 1 plus x to the minus 2. Now we can use the chain rule here to actually work out this integral, can't we? So if I write the 3 at the front, and actually let's do the integral now. So 1 plus x to the minus 2, if I add 1 to the power, plus x to the minus 1, and divide by minus 1, times by 1 over the number in front of the x. Well, in this case, the number in front of the x is just 1. So let's get rid of that bit there, we don't need that. And this is all going between infinity and 0. So we've done the integration. Add 1 to the power, divide by the new number. So nice. Because this is a linear function, we can use that reverse chain rule kind of idea, which is helpful. Okay, so what have we got? Let's tidy this up a bit. We've got negative 1 over 1 plus x between infinity and 0. So it looks really mathematically dodgy to now substitute infinity in there. So what I'm going to do is just use a different variable. I'm going to use r here. Minus negative 1 over 1 plus 0. There we go. And what I'm going to do now, most trickily, is I'm going to say let r tend towards infinity. So what happens to this fraction here as r tends towards infinity? As r is really, really huge, 1 over a really huge number plus 1 is going to be really close to 0. On the negative side, but really, really close to 0. And we can say as r tends to infinity, using the idea of limits, as r tends towards infinity, that fraction there tends towards 0. So what do we have? 3, that's going to tend towards 0. And this fraction over here in the second bracket, 1 over 1 plus 0 is just 1, so negative 1, that's just going to be plus 1. So 3 times 1 is 3. Okay? So the area underneath that curve looks like it should be infinite, is actually only 3.